Good morning, problem solvers and critical thinkers. It's Mrs. Post here. Today is Tuesday, April 14th. Today we are going to continue working on chapter 10, which is identifying features of a model, and this is from problem solving. So remember, problem solving means this is a time for you guys to really work together and try to figure out what's the question asking, what is the question missing, and how can you solve the problem. So a couple of things I want to go over with you guys really quickly. When you go to Teams and you are in thinking skills, when you're in here, I went ahead and I posted the weekly newsletter. And so you know that there's an assignment for every day, and they're usually pretty short because I've seen some of the work you guys are getting, and some of the assignments for thinking skills are very short. Sometimes they're just like 2 or maybe 4 questions, and you're just usually writing a sentence or maybe even less than a paragraph, right? So this is definitely something you guys are able to handle. This is your only ACE class you have. So the fact that you have that much work to do, this should not be any problem with you guys completing your thinking skills work. I need to send you guys a video today on the actual plans for getting your thinking skills credit, your ACE credit, because as you know, there is no more testing. There's no ACE tests right now. And so what we're having to do is submit to Cambridge. We're having to submit them your work samples from before we went to remote learning. So as you guys know, I'm also trying to get some of your work from now, but we'll see if that's possible. I don't know if they want the remote learning work because, because of academic integrity concerns. So I'll be working on sending you guys some of that. But as of right now, we have to make sure you guys are doing your part. And so anyway, so with the weekly newsletter, it tells you my help times. So you guys can ask me questions live at any of these times, but you can also ask me questions privately in the chat anytime, and I'll respond to you as soon as I can during that day. And like I say, I added a problem solving channel for you guys to work on. That's not where you turn in your work, but you guys are welcome to do that. And I'll put on there the actual assignment you can work on together, and then you guys can just talk about it and below it, like reply to that posting. Don't forget, I do have a YouTube channel where I've been putting all of the videos, and I need to kind of address that right now because this is not the one, this is it. So as you guys can see, this is the video from yesterday, no views. Okay, 9 views. Do you see what I'm saying? Thinking skills. There's absolutely no reason why you guys should not be watching your video lessons from your ACE class. There's absolutely no reason why. So with that in mind, just know that I need to have your notes returned to me. So if I give you notes and you guys are doing an assignment, I need to see the notes with the assignment. I'm going to put them together and you need to return them. This is so I know that you're doing your part and you're listening to me and actually getting your lesson. Okay. So this video hopefully is not going to be very long. I try to keep them around 10 minutes or less. You do get one from me every day, but you need to get the lesson from me. Most of you do not have your textbook with you. Most of you do not. So you need to get information. And if you do not watch the video and you do not have a textbook, you might be doing the work incorrectly. I'm trying to give you feedback as best I can, but you guys have to do your part. And watching a 10-minute video from your teacher is your part, okay? So if I'm giving it to you, you guys need to be responsible and you need to take that information, write it down, follow up on it, and then return the work, bless you, to me. Okay, so a couple other things. Let me go back to our right here. So then I told you, okay, yesterday's work, you don't have to do it. It wasn't due until this evening. Today's work, you can do it this evening. It's just a couple of problems. You guys are welcome to work on it together. You have an assignment here. I put every single date on here on the weekly newsletter and when it's due. All right. You don't have the files yet, but you have what we're doing. So you can kind of like manage your time. If you look on Thursday, there is a worksheet I will give you. 2 problems. Look at this. 10 points. It's due Thursday night. So be on the lookout for that. If it says 10 points, that's mastery. That's going in the gradebook. Do not skip those assignments. Some of you guys are skipping the mastery assignments. They go in the gradebook as a 0. Do not do that. Okay? We're going to review that, and then you have a chapter review after that. Next week, plan for a 20-point assessment. Okay, on the same topic. So you're getting a 10-point one that we're going to do in class after we've been doing this for a few days, and then you will have a test on it next week. So I'm giving you a heads up. If it says 10 points, that's mastery. You need to do it. If it says 5 points, that's mastery. If it says 20 points, it's mastery. You have no grades in teams. All of your grades are in PowerSchool. Okay, so your work has to be submitted in Teams. It's kind of like our online classroom. That's where we get your work and I assign your work. It's kind of like an online classroom. But your grade book is in PowerSchool. Okay, that's why nothing in here is showing points, but I'm doing that so you guys know. So when you go to the problem solvers tab over here, and I kind of put, like yesterday, I put problem solvers can work together to solve activity 10.1. Nobody replied. Today, problem solvers can work to solve 10.2, and then problem solvers can work to solve 10.3. So you guys are welcome. And 10.3 is actually like a little game. So you guys might want to try to do that. You just hit reply, and then you guys can go ahead and type your feedback or your comments or your, what do you guys think about this? I think it's this. Okay, you guys don't know. You have to talk to each other. And even if you all work together, you might not be right. Who knows? But you need to at least try. Okay, so please use the problem solver channel for the actual problem solving. Okay, so that's to help you guys. So you have this to help you, you have me to help you, and you have the video lessons to help you. Okay, and you have your lessons and your lesson notes to help you. You got to do your part. The only way you get better at things is to do it, right? So if you don't do it, you're not going to get better at it. That's just the truth. Sorry to be a bearer of bad news. I know you guys have stuff going on. We've all got stuff going on, but you got to reach out for help, and you just staying busy kind of helps get your mind off stuff, okay? All right, so this is what you guys are going to do today. So this is features of a model, non-standing representations. This is kind of the lesson I want to go over today. And then you have a couple of problems right here for you guys to work on together. So I want to go over this one, but the first thing I'm going to do is go back to the problem from yesterday. This is what you guys did yesterday. It's what you were supposed to do yesterday. This is what I wanted you guys to work on together. So it's 10.1. It says, what do the graph and images tell us about the trends in the use of smartphones in the USA? So hopefully you guys will notice there are no actual like coordinates here, and it's not that they're not necessarily all straight lines. They're a little curvy, a little wiggly, some are linear. So it says the trends in the use of smartphones in the USA. Well, it looks like smartphones are green. Smartphones are also dashed. The green line and the dashed lines are all going up to the right, so it looks like they are increasing in usage. You can see in 2014, they had somewhere around 25%. 30% of people were using smartphones to get their news, okay? The use of smartphones in the USA. Because it says digital news report, which is your main device for accessing online news. Okay, so that's what this is about, changing device use. So you can see that through the years, more people are using these devices to get their news, which is true. Weirdly enough, though, I did just subscribe to the newspaper for Sunday, but I also think it was just for fun, just to get the sales flyers and stuff like that. So anyway, and then also you look at computer, looks like this is blue or purple. This is, yeah, I think it's blue or purple. It's going down to the right. So you can see it's definitely decreasing. Less people are getting their news from the computer. They're getting it just from their handheld device. Because you can just get a news app on your phone and there you go, right? And some of you guys are really good at getting the news from your devices. Even you guys in ninth grade are getting the news, and you guys have report to me interesting information because I don't usually read the paper. I don't usually have time to sit and read it on the computer. So if I don't check my phone, then yeah, I don't really know what's going on. Except for now. I do watch the news a lot more now that we've been home. So anyway, so those are a couple of things to think about. So hopefully you guys were able to write something like this. Smartphone usage is increasing. Tablet usage is at least constant. You can see tablet usage is orange, just kind of staying the same. People are just using it around the same, no more, no less through the years. If they're going to use their tablet, they're going to use their tablet. Like my uncle uses his tablet a lot. His iPad uses it for games, uses it for news, uses it. I think it's just because the screen is bigger than a phone. Anyway, and then of course computer usage is declining. We just talked about that. And just a couple other things to consider. There are no values of usage. We don't know like what the actual number was in 2014, 15, 16, or 17 for these particular devices. We don't know that. So we can't necessarily get the slope. We can tell if it's increasing or decreasing, but we don't have any values. The graphs are generally not linear. They look kind of linear, but it's not constant. Like they're a little they're a little not necessarily slanted, but you see how they kind of go and then they kind of drop and they kind of go, oh, not a straight line. The only one that looks kind of straight is the tablet. That one looks really, really constant. That one definitely has not changed. So that one really doesn't even have a slope. It's just the same. It really hasn't changed any. Okay, so that's just what I wanted you guys to kind of write out for this problem. Those would have been correct answers for this one. So had you done something like that, that would have been cool. I asked you guys to try to see if you can get numerical values. And if you had, that would have been great, but it's, up to you guys. So I'm kind of curious to see what you guys did for that. Anyway, so that was your problem from yesterday. Let's go into our problems for today. This is where we are today. Right here, and I'm going to send you guys this file right here as a Word document. If you want it as a PDF, let me know. I can change it and send it to you as a PDF as well. Then you guys can just write on it. So features of a model, non-standing representation. So I'm just going to read it to you guys. Some graphical representations of information are not the usual sort of graphs that you might have studied in school. These are sometimes referred to as infographics and may combine different types of information in a way that is easy to understand and which may also be rather beautiful. How cool is that? It's also beautiful. And I do kind of like this graph. I do think it is kind of beautiful. It's easy to understand and also rather beautiful. Okay, so interesting. I do kind of think it's beautiful. All right, so let's look at this graph right here. A key part of driving safely is knowing how much of a gap to leave between you and the vehicle in front of you. The distance you need to leave is known as the stopping distance, and this is shown in the following diagrams. This is information for you guys who are soon to be drivers next year. And who are starting to practice driving. It says here, the distances shown are a general guide. The distance will depend on your attention thinking distance. The road surface, the weather conditions, and the conditions of your vehicle at the time. So all of these factors are taken into account, right? These alternative explanations if the numbers are a little bit off. So, and you can see right here, it says an average car length is 4 meters or 13 feet. So you have your thinking distance and your braking distance together. Thinking is in blue, braking is in red. And I wrote some notes on this. Okay, and question number 1 says, can you work out what each part of the diagram tells us? Well, let me see if I can kind of add here. So for number 1, can you work out what each part of the diagram tells us? Well, hopefully you guys will notice the left side shows us, if you look at the very far side, it says 20 miles per hour, 30, 40, 50, 60, 70 miles per hour. Left side shows us the car or the driver's speed, like how fast the car is going before it brakes, right? Oops, let me go back. The right side shows us the stopping distance. And hopefully you guys will notice that the blue is actually the thinking distance. And the red is the braking distance. This is kind of what you guys are just doing. You're just summarizing the information from the graph, okay? And I do kind of like this infograph. Okay, let's see. What else do we need to know? It looks like you are adding, like if you look at if the car is going 20 miles per hour, if you look at it, 6 for thinking, 6 for braking is 12. So that's where it gives you that information, 12 meters or 40 feet. Okay, so that's how long it would take the car to actually stop. That's how far, not how long, how far. And if you look at 30, if you notice it goes from 9 meters is the thinking, 14 meters is the braking, and then it says 23 meters or 75 feet or 6 car lengths. Because if you think about it, 9 plus 14 is 23, right? And if you look at the 40 mile per hour, 12 and 24 should give you 36. You see what's happening here? If you're driving at 50 miles per hour, 15 plus 38 is 53 meters, 60 miles per hour. You can see it looks like they're adding. So I'm going to make a little note here that also says the thinking and braking are added to find the stopping distance. Okay, so that's number one. Can you work out what each part of the diagram tells us? Okay. Also, a couple other things here to think about. Okay, so I wanted to know if you guys could kind of notice something about the thinking distance, which is in blue. So a couple things about the thinking distance. It says it goes from 6, 9, 12, 15, 18, and 21. Hopefully you guys are noticing that that is increasing by 3 every single time. So hopefully what you guys are noticing is that that's kind of like a constant increase of 3 every single time, even though the car is driving at a faster speed every time. Looks like the thinking distance is the same. So we're all going to think the same, but it's just going to take us longer. Well, it's not going to take us longer. The car is going to travel further. Because if you're driving faster, you're going to travel a longer stretch. You're going to travel more meters because your car is going faster. So even though it takes us the same processing time in our brain, the car in that time has traveled a further distance the faster you go, right? So if you're driving this fast, it's going to take you this long to process this far. And then if you're driving faster, you're going to get this far before you can stop and this far before you can stop. So the car travels further in the same time because it is going faster, even though thinking reaction time. Okay, so that's why those numbers are, they're adding a little bit more to it because the speed of the car is traveling more of a distance. All right, and let's kind of think about the numbers for the braking distance. Hopefully you guys can see it. We're going from 6 to 14 to 24, oops, to 38 to 55 and to 75 here. Okay, so with this one, I want you guys to be thinking, okay, is there a constant increase? 6 to 14, looks like that is 8, 14 to 24. If you notice this is going, that's 8, that's plus 10, 24 to 38, what is that, 14? And then we're going to add 17 here, and then that's going to be plus, I think I have 20 here. So it's not a constant increase, or the increase is not the same every single time. So let's see. And that definitely could be due to the other factors that we kind of mentioned. Just make a little note. Not constant. Pattern or linear. Okay, so it's not the same exact amount every single time. Okay, let's see. It asked us for something else. I think we got that already. And we could say that this could be due to those alternative options. So the road surface, weather, vehicle condition. Some cars, you know, stop faster. They have better tires, something like that. Things like that. Okay. So, and let's just, so that's what it wanted you to do. And that's kind of like the problem that you guys did yesterday. We're just kind of analyzing the data, going through what you see and just making sense out of it. Okay. So let's go to number 2. And number 2 says, what is the stopping distance at 35 miles per hour? So 35 miles per hour is somewhere in between 30 and 40. And it looks like 30 miles per hour is about 75 feet or 23 meters. And then 40 miles per hour is about 36 meters or 118 feet. So I would just say if 35 is in between 30 and 40, I would say, and the question is, what is the stopping distance? the stopping distance at 35 miles per hour is approximately between 75 feet to 118 feet. And I just got that from the diagram. Okay, and you could use the meters because that's what it mentions up here on the diagram. So that's really all I needed you guys to do. So when you're getting questions like, what does the diagram tell us? You're kind of thinking about it in words, okay? And then you should be able to calculate the or discover the other question, okay? So what you guys are going to do today, you guys are going to do activity 10.2 and 10.3. You guys can do it in the channel together and then send in your final decision of what you guys think the answer is, okay? For 10.2 and 10.3. A couple things about 10.2. It's talking about circumference. A couple things you guys might need to know. You might need to do some conversions, and you're welcome to look that up, such as inches to inches or centimeters, or I think it also talks about kilometers. So you might need to do some kind of conversion if necessary. Okay, and that's okay. If you need to look that up, you can, because you're doing this from home. So we might need some conversions, and it's okay to look that up, okay? You're welcome to do that. And then this last one is a game. You can play this with anybody in the channel, or you can play it with anybody in the house. With you, it's pretty quick, and you're just trying to figure out the strategy. So this is the question. Can you find a strategy to help you win? Think of like tic-tac-toe. You know, there are some simple strategies. And then 10.2 is, how can you work out that the author of the article made a mistake? That's your question. Please make sure you are answering the actual question where the question mark is. Okay, that's one of the mistakes I see you guys make, is just not answering the question, doing what they're asking you to do. Okay, so make sure you read that carefully, use the channel, and you guys are going to get these documents in just a minute. You guys can work together over here in the Problem Solver channel. All right, you guys, be sure to send that in by the end of the day, and have a fabulous day. And if you need me, I am here, and I will talk to you guys later. Bye. Have a good day.